All right, this is Geometry, Lesson 8, Part 2, and we're going to do the Build Your Skills 1, 2, and 3. Melanie says that since a dodecagon has twice as many angles as a hexagon, so hexagon's got 6, dodecagon's got 12, the angles in a regular dodecagon will be half the size of those in a hexagon. Is she right or wrong? Calculate the size of each of the angles of a regular dodecagon to verify your conclusion. Okay, so we need to figure out the size of angles in a dodecagon. So number one, we should find the total or the sum. So I'm going to replace sum with total, and I'm using the equation from the last lesson. So go 180 times n minus 2. So the total would be 180, and n is 12 minus 2. And then we got 180 times 10. So the total of all the interior angles of a dodecagon is 1800 degrees. Now, if we take our total and go 1800 and divide it by 12 angles, each one is 150 degrees for each angle. Okay. Well, a hexagon, we figured out in the last lesson, has an interior angle of 120. And she was saying that a dodecagon will have angles half the size. Well, not only was she wrong about it, the amount being wrong, but the angle actually got larger. So a dodecagon has angles of 150, which are actually larger. So she is incorrect. Okay. Fill in the table below, showing the size of each of the interior angles for each regular polygon. And for a triangle with all sides being equal and all angles being equal is 60. We know that from equilateral. A square is 90 degrees, each of them, if all the sides were the same length. So just a reminder, what we're doing is we're finding interior angles. And for pentagons, it is 108. We're not going to go through and do each calculation. I'm just going to give them to you on a table here. Hexagon is 120, so the angle seems to go up. Heptagon actually comes out to 128.57. Octagon is 135. Nonagon is 140. Decagon is 144. And dodecagon is 150. Okay. And for this to be true, all sides and angles must be the same. Okay, just a reminder, that's the only way for this to work. Often you'll see the word congruent for sides. So all these sides have to be equal length. Okay. Number 3. What regular polygon is approximated by joining the ends of the petals to the flower? And what is the angle at each vertex? Okay, so they're saying if you join from here to here, down to here, draw that a little better. Over to here, down to here, like that. That looks like a pentagon. 5 sides. And that would mean the angle at each vertice. If we look back on our table, the angles are 108 degrees each. Okay, that is the end of lesson 8, part 2.